We did our project on the Physics Behind Amusement Parks, and we are going to talk about different concepts that we have learned in class and how they are used throughout different rides.
Non-constant velocity occurs when an object accelerates. An acceleration occurs when there is a change in speed, a change in direction, or a change in both. Non-constant velocity can be demonstrated in the real world through roller coasters, and more specifically roller coasters accelerating along a track. For example, let's say you're riding a roller coaster at Great America going 5 miles an hour and you're about to go down a big hill. If it takes 4 seconds to get to the bottom of the hill, what is your final speed? If we plug in all of these numbers into the equation, the final velocity equals acceleration times time plus your initial velocity. You'll get a final velocity of 44.2 meters a second.
In physics, waves are a vibration accompanied by a transfer of energy that travels through a space or mass. The basics of waves can also be shown with a roller coaster. For example, a roller coaster is traveling along a track at a constant speed and moving up and down over hills in the shape of a wave. You measure with a stopwatch that it takes 4.2 seconds for the cart to complete one wave motion. What is the cart's frequency? You can easily find the frequency by plugging the period of the wave into the equation frequency equals 1 over period. The frequency ends up being 0.238 Hz. Also, given the velocity of the coaster from the first problem and the frequency from the second, we can find the wavelength using the equation velocity equals wavelength times frequency. If we plug in the data from the previous questions, we will get 185.71 meters.
Circular motion is a movement of an object along the circumference of a circle or a rotation along a circular path. We see circular motion demonstrated in real life in a carousel. Given the measurements of the carousel itself, and after finding out the time it takes for one rotation, we can find its velocity. For example, you measure the radius of a carousel to be 25 meters. You then time how long it takes for a complete rotation and get 7 seconds. What is the velocity of the carousel? To find the answer to this problem, we use the equation v equals 2 pi r divided by time. After plugging in all the data, you will find the velocity of the carousel to be 22.44 meters a second.
There are many different types of energy, but we will be talking about GPE and KE. GPE is an object's gravitational potential energy and is affected by an object's mass and height. KE is an object's kinetic energy and is affected by an object's velocity and mass. An example for both of these concepts would be drop zone, or any ride that drops people from an extreme height. Let's say a ride lifts a 1,000 kilogram mass up to the top of the ride, which has a height of 150 meters. What would the GPE of the load be? Using the equation GPE equals mass times gravitational times height, we can find the potential energy to be 1,470,000 joules. Now, let's say we want to find the kinetic energy of this ride given its velocity of 25 meters per second. We can use this velocity and the same mass from the last problem and plug them into the equation KE equals 1/2 mass times velocity squared. The final kinetic energy you will get is 7,812,500 joules.
Force is the strength or energy of any physical action or movement, an example being a push or a pull. The forces acting on an object can be demonstrated with a force diagram, labeled with arrows that represent the forces acting upon the object. Here you see the gondolas at the boardwalk, which have four forces acting on them: the force of earth, the force of the cable, the force of friction, and the force of the cable again in the horizontal direction. It looks like this.
Momentum is represented in physics as delta P and is affected by an object's mass and velocity. An example of momentum in an amusement park is bumper cars. Two bumper cars that both have a mass of 225 kilograms are stopped and start to travel towards each other at both 5 meters per second and 7 meters per second. What is the momentum for both cars? We can find the answer by plugging in the velocity and mass of both cars into the equation delta P equals mass times delta V to get 1,125 kilograms meters per second and 1,575 kilograms meters per second.